Let's have a look at the quadratic formula. So suppose you have a function y equals ax squared plus bx plus c. That's a general quadratic equation. It's going to look something like that, or maybe like that. It's either going to be, if a is positive, it's that. If a is less than 0, it's that. Question is, how do we find these points where ax squared plus bx plus c equals 0? And at schools they teach that x equals minus b plus or minus root b squared minus 4ac all over 2a, which is really stupid. I mean, it's not wrong, but it's just ugly and cumbersome, and it's just going to make people hate maths. So let's look at this in a slightly more sensible way. For a start, if you're trying to find that equal to 0, why not just divide through by a straight off and get, that's saying the same thing as x squared plus b over a x plus c over a equals 0. So straight away we've written it more simply. X squared plus p x plus q equals 0. So there's really no place for this formula. Straight away get rid of a by dividing through, and then you've simplified this thing to, what is it now, minus well, okay, let's see what the formula comes out for this. So the trick is to say, this is called completing the square, x plus, now if I made that 2px, then I'm going to say x plus p squared. Well, what is x plus p squared? X squared plus 2px plus p squared, which is pretty similar to what we've got here. If we were to subtract the p squared and we were to add the q, we would actually have the same thing. So x plus p squared minus p squared plus q is the same thing as x squared plus 2px plus q. Notice the triple equals. This means they're identical to. The equals means only for a certain x is this true, and you've got to find x. But this is saying we're just writing the same thing different ways. Like I could say a plus a is the same thing as 2a. Yeah? Okay, now it looks a bit weird. This kind of looks nicer than this. But this has x squared and x, and they're quite hard to... It's difficult to isolate x in this form, but here x is only written once. So if you're trying to solve this equal to 0, then that's just x plus p squared minus p squared plus q equals 0. Move this stuff to the other side. X plus p squared equals p squared minus q. So x plus p equals, and square root both sides, p squared minus q. You've got to remember that when you square root, because take 4 and you square root it, so 2 times 2 equals 4, but also minus 2 times minus 2 equals 4. So by convention we say this is the positive square root of 4, so that is equal to 2. So by putting plus or minus, we're actually stipulating plus or minus 2. Yeah? That's an aside, so I'll put that up there. So there we have x equals minus p plus or minus root p squared minus q. And that looks a whole lot nicer than this. So if we make I'll make up an example. X squared 2x squared minus 6x plus 4 equals 0. So we get rid of our coefficient of x squared. X squared minus 3x plus 2 equals 0. So 2p is minus 3 and q is 2. So p equals minus 3 over 2, q equals 2. Throw it into the formula and you get x equals minus p, 3 over 2, plus or minus root p squared minus q. Minus 3 times minus 3 is 9 over 4 minus q minus 2. So 2 I can write as 8 over 4. So 9 over 4 minus 8 over 4 is 1 over 4, and square root of 1 over 4 is root 1 over root 4, which is 1 over root 4, which is 1 over 2. So equals 3 over 2 plus or minus a half, which is 4 over 2, otherwise known as 2, or 2 over 2, otherwise known as 1. And we could do a quick check. We could throw x equals 2 into there, and 2 times 2 squared, 2 times 4 is 8, minus 6, 2, 12, 8 minus 12 is minus 4, plus 4 is 0, correct. 1, 2 minus 6 plus 4 is 0, so, yep, it checks out. So once you have the solutions, you could then write this as 2 times x minus that root times x minus that root. That is going to be the same thing as this, 2x squared minus 6x plus 4. If you want to check, we've got x minus 2, so that's x plus minus 2 along there, and we've got x plus minus 1 here. So x times x is x squared, minus 2 times x, minus 2x, minus 1x there. Minus 1 times minus 2 is 2. So I've got x squared minus 2x minus another x minus 3x plus 2, but I'm multiplying the whole thing by 2, so 2x squared minus 6x plus 4. Okay, so if you have the factored form, it makes it really easy to see the roots. I mean, they're just there. Yeah, if you've got x minus alpha, x minus beta, let's make this a cubic, x minus gamma, you know your roots are alpha, beta, and gamma. So this equation is for finding the roots for the quadratic. Once you have the roots, you can then write it as x minus alpha, x minus beta. Maybe there's a coefficient in front. That would be your a, actually. K would just be a. And by the way, that's why I paused before choosing the example, because I started out with this in my head and I just multiplied it out and wrote it down, because I wanted to make an example that would have nice numbers coming out. Okay, so this is I don't want to waste effort showing why you get this formula, because this is a nicer formula. I prefer this formula. If you were to substitute p as what was p, 2p was b over a, so p was b over 2a, and q was c over a. If you were to substitute this into here and do another 5 or 6 lines, you would get out this formula. But you never need it. You just divide through by a, and suddenly you've got this situation, and it solves very nicely. Completing the square, that's the key buzzword, which we did here. We should put a little square here as well to show that we're done. Okay, that's all.